Okay, so today I will show you how to create those fuel and coolant temperature gauges with the Arduino and the VFD display. And the VFD stands for the vacuum fluorescent display, and it's a display with this nice bluish or greenish kind of glow. And VFD displays were used a lot in cars long time ago. And actually the reason for this project is quite simple. A friend of mine has the older car, the 1994 Honda Prelude with VFD gauges, and after 30 years they just stopped working. So he asked me if I can help him replace those two gauges with a different display, and I think that replacing the original segmented VFD display with the graphical VFD display makes a lot of sense. You know, just to keep the same appearance, and also I like VFD displays. By the way, I have one video with VFD displays, that's this one with a nice segmented clock and 40x2 character display. I've also used this 16x2 VFD character display to show the 3D rotating cube. That was a fun project. Also, I have this transparent VFD clock, simply because I like VFD displays. Before we start, let's talk about the sponsor of today's video, which is PCB Way. And that's because if you are making projects like this, you might need PCB or maybe SMD stencils or PCB assembly. And PCB Way has you covered. They offer all of those services for a reasonable price. And actually, I do need something for today's project. I needed those black semi-transparent overlays because they make it much easier to capture the display on the camera, and they just improve the contrast in general. However, getting this on the PCB Way website is slightly hidden. You have to go to all services and select the laser cutting because this is the acrylic sheet being cut with laser, and then I will click the get a quote button, and this might be a little bit confusing because it's saying sheet metal, but we can switch from the metal to acrylic. But unfortunately the only option is a clear acrylic, so we have to actually switch to custom metal and type in semi-transparent dark acrylic. Then you just upload one of the supported files, and that's pretty much it. So thank you PCB Way for sponsoring this video, and let's get back to our project. So again, for this project I will be using the Arduino UNO, but you can use any Arduino board and this big graphical VFD display module with the resolution of 256 by 50 pixels. If I flip it around, it says it's from EEI Technology. It has some connectors, but unfortunately those are not labeled on the PCB. But at least you can see that there is this power jack and the USB Type-C connector for powering up the display. I will be using the USB-C cable for power. And there are also two audio connectors which I will not be using. And on the front of the module there is a light sensor, which I might use the next time for setting up the brightness of the display. As with all the VFD displays, those displays are using a high voltage, and while it doesn't have enough power to hurt you, it's not a pleasant experience, and I would not suggest touching anything on the PCB or any components while it's being powered up. You can see it says high voltage here on the PCB. As for using this module, the AliExpress page where I purchased this display had some images like this one, showing some kind of clock, and this image which is some kind of test pattern. There was also this video showing the clock project again, and the video of this demo sketch running. I've also found the image of the schematics, and the most important part is this image that shows the labels for those two connectors on the back of the PCB. Again, I don't understand why they are not labeled on the PCB itself. Thankfully, the name of the display itself is printed on the PCB, and that's this GP1287. And as I was searching for the name of the display, I found this project from Mirko Pavlevsky, which uses the very same display. And on this page you can see all the details, you can see the image of the display, you can see also the image of the project itself, as well as the connections, and it looks like that the ESP chip was used instead of the Arduino, but that shouldn't make any big difference. We will get to the connections in a minute, but right now I want to take a look at the Arduino code, so I'll just copy this code into the clipboard and paste that code into the Arduino IDE. And it looks like it's using the U8G2 library. Actually, it's using the U8x8 library, which is a very simplified version of the U8G2 library. It doesn't use any frame buffer, but instead it splits the display into the 8x8 pixel tiles, and you can control those individual tiles instead of controlling individual pixels. So this is mainly used for rendering text, but again, it should be enough to get us started, and later on we can switch to the full-featured U8G2 library. I will start by deleting most of the code. I don't need those commands, and I don't need to include the ESP, Wi-Fi and time libraries. I only need the U8G, actually the U8x8 library. I don't need any of those defines or variables. I only need to keep the initialization line for the display, which is this one. And then inside the setup, I need to keep the U8x8 begin function, but the rest of the setup function could be deleted. And then inside the main loop, it looks like that we are calling the showTime function, and that will draw the stuff on the display, and I will maybe select this piece of code for setting the font, setting the cursor, and printing something to the display, and put this into the main loop function, and again delete the rest of the code. I don't need to use the sprintf function because I will be printing some predefined text, and of course I will start with the hello world message. Now this U8x8 library might be a little bit confusing, because if you want to use it in your sketch, you need to install the U8G2 library, which is this one, and not that one. And since I already have this installed, I can just close the library manager. And let's take a closer look at the initialization of the display. This is the U8x8 library, this is the name of the display, this is the resolution, 256 by 50 pixels. The 4W stands for 4-wire SPI connection, and the SV stands for software. So we are using the software emulated SPI connection, which means that everything will be slower, but the advantage is that we can use any pins. That said, I would like to use the hardware SPI connection later on to get a better speed, so I will try to use those pins to use the hardware SPI pins, and for the Arduino UNO, the hardware SPI pin for the clock is pin number 13. And the SPI data pin, that's the data coming from the Arduino to the display, that's the pin number 11. The CS pin, the chip select pin, could be any pin, so I'll for example use the pin number 10. And the DC pin for switching between data and comments, again could be any pin, but I don't think that this pin is being used with our display. We only have the clock pin, the chip select pin, the data pin and the reset pin. So if the pin is not being used, let me just open the original code. We should use this U8x8 pin none definition. So I will just copy this and use it for the DC pin. And finally for the reset pin, which we do have connected, we can again use any pin, and I will use the pin number 8. So with all of those pins defined, let's connect the Arduino to the PC and select it from this drop-down menu, and then hit the upload button. After the code is being uploaded to the Arduino UNO board, we need to connect the Arduino UNO to the display in the very same way as defined inside the code. And just in case, let me just disconnect the board from the USB power and then connect it based on our initialization code, which means that the clock pin should be connected to pin number 13, the chip select pin should be connected to pin number 10, the data pin should be connected to pin number 11, and the reset pin should be connected to pin number 8. There is one more pin that needs to be connected, and that's this filament EN pin, filament enable pin, and I will connect it to the 3.3 volt pin on the Arduino UNO to always keep it in the high state. Just in case, it might be also a good idea to connect the ground pin on the display to the ground pin on the Arduino UNO. And when I connect the display to the power using the USB-C cable and the Arduino to the power using also the USB cable, we should see the hello world message on the display. Now it's a little bit faded, so let's see if we can increase the brightness, and at the same time, let's see if we can switch to the hardware SPI connection instead of using the software SPI connection. As for the brightness, we can try to use the function called setContrast, which sets the contrast or the brightness of the display. So inside the setup, I will type in u8x8.setContrast and set it to the maximum value of 255, and then upload it to the Arduino UNO. And indeed, now the hello world label is much brighter. So let's also switch to the hardware SPI connection, and again we are already using the hardware SPI pins on the Arduino board, so we will not change the actual physical connection, but we need to change the initialization line in the Arduino code. And that's this line, so I will just copy the name of the initialization line, and then I will jump back into the U8G2 documentation and open the U8x8 Arduino setup page. And in here I will search for our initialization, which is this one, the software SPI connection, and we want to switch to the hardware SPI connection instead, so I'll just copy this line and paste it into the Arduino IDE, and of course I need to include the U8x8 name, and then I need to define the CS pin, the DC pin and the reset pin. The reset is optional, but I don't need to define the clock pin and the data pin because again those two pins are defined on the board itself. So just copy the CS pin, DC pin and the reset pin into the initialization line. add the semicolon, and this will be hardware SPI connection. Then I will comment out the software SPI connection initialization and upload it to the Arduino UNO board. And while there is no visual difference on the display itself, it's still showing the hello world message. We are now using the hardware SPI connection, which means that the data from the Arduino to the display are now being sent much faster. And while it doesn't make much difference for a static message, it will make a difference once we start animating stuff. And to animate stuff and to draw images, we need to switch from the U8x8 library to the fully featured U8G2 library. And when I open the documentation for the U8G2 Arduino setup, which is this page, our display should be there, which is again this GP1287, but when I click this link, nothing happens. And it looks like that the part of the page is missing, it's just not complete. But thankfully I was able to find this page where a similar VFD display is being used, and there are also all the initialization lines listed for this display. So I will borrow this line for the initialization of the display using the full screen frame buffer with the hardware SPI connection, and just copy this into our sketch. And I will just replace the used display with our display being the GP1287 instead of the old one. Now inside the initialization I need to define the rotation, then the CS pin, DC pin and the reset pin, and it looks like that those pins are matching our pins, so that's great. But our code is still using the U8x8 library instead of the U8G2 library. So what I will do is I will open my older video called Image to OLED in 60 seconds, because in the description there should be a link to the Walkway project. And Walkway is a free online Arduino emulator, and all I'm doing here is to just show the full screen image on the OLED display. So let me just copy all that code into the clipboard, so everything inside this sketch I will just copy and paste it into our Arduino sketch, and delete those old initializations and used this one for our current sketch. Just like that, and let me just collapse the definition of the full screen image so we can see the setup function and the main loop. And what I'm doing in here is again calling the begin function, and then I will also add our U8G2.setContrast function, again all the way to 255. And then inside the main loop, I'm clearing the buffer, drawing the image to the buffer, and then sending the buffer to the display. Also, I've changed the name of the display, but I did forget to change the resolution, which should be 256 by 50 pixels. So let's see what happens if I try to upload this sketch to the Arduino board. And there is a problem because we are out of memory. And the main reason for that is the full screen frame buffer, because we have the 256 by 50 pixel screen, so we need that many bits, or if I divide it by 8, we need that many bytes, so 1.5 kilobytes. And we only have 2 kilobytes of RAM memory on the Arduino UNO board, so if I just minus 248, we only have about 440 bytes for everything else, which doesn't seem to be enough. Thankfully there is a way how to use the U8G2 library, even if we don't have enough memory for the full screen frame buffer. And we do it by lowering the buffer size, so instead of using the F for the full screen frame buffer, we use number 1 for the page mode. And in the page mode the buffer is only 8 pixels tall, which means that we only need 256 by 8, so that many bits, or divided by 8, that many bytes, so 256 bytes. And then the U8G2 library will redraw first page and then send it to the display, then redraw second page, send it to the display, and so on and so on. So the actual performance will be slightly worse, but we will only need 256 bytes for the frame buffer. And the first thing to do to use the page mode is to change the initialization line, so instead of using F, I will use 1 for the page mode. And then in the U8G2 documentation, there is a description of different buffer types, and I want to switch to the page mode, which requires to have this loop inside the main loop. So just copy this code and paste that into my main loop. And this time I don't need to clear the buffer and I don't need to send the buffer to the display. I just need to draw the image inside this U8G2 page buffer loop like so. And I believe that's all that we need, so let's try to upload it to the Arduino UNO one more time. And it seems like that we don't have the memory problem anymore. And we do see this menu image on the display itself. Now this image was made for the 128 by 64 pixel OLED display, so as you can see we are missing the bottom part of the image because the height of our display is only 50 pixels. And also the right half of the display is empty because the image is 128 pixels wide and our display has the width of 256 pixels. But we know that displaying image works, and we should be able to create our own image in the resolution of 256 by 50 pixels. So let's actually do that. Let's draw the image of two gauges in an online tool called Photopea. And Photopea is a free online graphic editor similar to Photoshop, so just jump in there and create a new file with the resolution of our display, which is 256 by 50 pixels, with the black background, and hit the create button. And then of course zoom in as much as I can, and just for the sake of my explanation I will create a new color fill layer in the dark gray color, again that's just for myself, so you can see what's going on. But what I really want to do is to select the selection tool, the rectangular selection tool, and I want to create two gauges, one on the left side and the other one on the right side. So I'll select a selection, for example, I don't know, maybe like 120 by let's say 13 pixels. And then I will create a new layer by clicking this new layer icon, and then I want to fill this selection with the white color by, for example, going into the edit, fill, and selecting fill with white color and click the OK button. And let's just move it around, I don't know, maybe like so. That will be first gauge, and let's just duplicate this layer and move it on the right side, and that will be the second gauge. Now I want to use this image as a reference, and if I count the number of tick marks for the fuel gauge, there are 20 of those. Which means that for our gauge, which is 120 pixels wide, divided by 20, we need to have a tick mark every 6 pixels. So let's create a new layer and zoom in a little bit more, like so. And then I will, for example, select the pencil tool, set the size to be only 1 pixel, and clicking this icon, set the black foreground color. And then draw the tick mark like so. And then using the arrow key, move it on the right side. So the white space is 5 pixels wide. And then I will create a copy, for example, by duplicating the layer and again move it 6 pixels to the right side. So 1, 2, 3, 4, 5, 6. And then I will continue like this with all the other tick marks. But I can also create a copy by pressing the Alt key on the keyboard and then pressing the right arrow. So 1, 2, 3, 4, 5, 6 and continue like this. Now once I have more of those tick marks, I can continue duplicating them more at the time, which will of course speed up the process. So this is the gauge with all the tick marks, so let's just select all those tick marks and group them by pressing Ctrl G. And then I will duplicate the group also for the right gauge, like so. But if I take a closer look at the tick marks on the fuel and temperature gauge, they are much bigger, so I might hide some of those tick marks, starting with hiding every second tick mark. So just click the eyeball icon, like so. And then just keep the first one and the last one smaller and the other ones to be slightly bigger, like so. So I need to hide a few more tick marks, and if I check this checkbox which says auto select, I can click on the layer and it will auto select me that layer, so I can easily hide it. So hide this layer and this tick mark and finally this tick mark. And then I will click the checkbox again because I don't want to auto select layers, but that's just a personal preference. I can simulate rounded corners on those gauges simply by placing few black pixels. So let's create a new layer and then zoom in as much as I can and select the pencil tool. Again, set the size to be only 1 pixel and then click on those corners on the left side as well as on the right side. And then duplicate this layer and move it also over the right gauge, like so. And of course you can see it better if I hide this gray layer, so those are two gauges. And then I want to draw those dots and lines below the gauges. So again, I will create a new layer and select the pencil tool, but this time I will set the size to be 5 pixels, which is the same size as 1 tick mark on the gauge. And I will draw the circle below the gauge like so, but of course I want to change this to be white color instead, so white circle. And then I will duplicate it and move it on the right side, and then do this one more time and align it with the right side of the gauge. And then select all 3 circles and set equal gaps. And then I will create one more layer and then change the size to be again 1 pixel only. And then draw the line from here to there. And I can do it by clicking on the left side, then pressing the Shift key on the keyboard and clicking on the right side. And that will create a line between 2 points. And of course I will do it one more time between the middle circle and the right circle, like so. Then I will select all 4 layers and again group them and duplicate them for the right gauge and of course move them to the right side. But you can see that the right gauge doesn't have the middle dot, so I'll just select it and hide it or delete it. And then as for the line itself, I will again select the pencil tool and connect those two lines together. The next step is adding those labels, and for that I need some pixel font. And this time I'm using the font called Pro Font, which you can download from this page. If you scroll down, there should be a link for Windows TTF file, which is this one. So click the download the zip file. And then back inside the Photopea, select the type tool, open the font settings and click the load font button. And select the TTF file and click open. And yes, I want to also use it the next time. And then open the drop-down menu again and find this Pro Font, which is this one of course. I will set the font to be white color and type something, for example E, but this seems to be quite big, so I'll lower the size to maybe only 12 pixels instead. And then move it close to the dot, and then create one more copy and move it to the right side, and this will be F for full. Then I need C for cold, and you can see that I have some grayscale pixels, which will not be possible to show on the display. So when I have the character selected, I will set the anti-aliasing method to be none, so no in between pixels. But this did make the character slightly worse looking, so I guess I will go back, I will undo this operation, and instead I will add a new effect being the threshold effect, that will convert the image to only use black and white colors. I still need to copy this one more time for the H, for the hot, and again move it to the right side, and finally there should be one label in between, saying 1/2 of the tank. And I might make this even smaller, for example only 9 pixels. So that should be it for the labels. And the only thing remaining are those two icons, the fuel icon and the coolant temperature icon. For that I will again create a new layer and then zoom in as much as I can, like so. Select the pencil tool, set the size to be only 1 pixel, being white color, and I can roughly start drawing the shape. Now if I don't like some pixel, I can delete it using the eraser tool with the mode being set to pencil, only 1 pixel, and then delete it like that. Or I can just keep the pencil tool selected, and if I swap the foreground and background color, which I can do with this icon or pressing the X on the keyboard, I can just draw over this icon with the black color instead. So let's draw the rough shape of the icon. And then when I'm happy with the result, I will just zoom out a little bit and use the move tool to move this icon around. The next step is to draw the coolant temperature icon using the very same steps. So create a new layer, select the pencil tool, of course zoom in as much as I can first, and start filling those individual pixels. Maybe like that, and then again zoom out and try to align it to the middle of the gauge. And I think that at this point we have our gauge design finished and ready to be shown on the display. To do that, we need to first export it as the PNG image by going to File, Export as PNG Image. Keep the default settings and then click the Save button. So this is the exported PNG file, and then we need to convert it into the C-style array using the Image to CPP website. So open that page and then select our image. Down here it will show you the preview. The only thing that I need to check is to check this swap bits in byte checkbox, and then click the generate code and copy the output. And while we still have the data in the clipboard, I will jump to the Arduino IDE and delete the old image definition, which is this one, and then paste the content. And I don't need this helper array, but I do need to know the name of the image, which is this one. So just copy the name into the clipboard. And when I'm drawing the image, I need to change the name to match our new name, and of course change the dimensions to be 256 by 50 pixels. And with that change, the only thing left to do is to again upload it to the Arduino board. And we should see our image on the VFD display, and I think it looks great. With those big green shiny pixels, it's got that retro-futuristic look. But let's move on. We know how to show the full screen image, so now it's time to animate it, and by animating it I mean showing parts of the gauges or filling those gauges. And I think that the easiest way how to animate those gauges is to still draw the full screen background image, but then we will draw black rectangles on top of it to cover parts of those gauges. And of course by changing the size, the width of those rectangles, we will be animating those gauges. So let's do that. Let's jump back into the Arduino IDE and let's create a new variable called fuel value and set it to 0, and that will set how much we want to cover the gauge, so it will go from 0 to 220. And let's actually create one more variable called fuel value increment and set it to +1, because I want to animate the fuel value. So I'll just say that the fuel value is the fuel value plus the fuel value increment, and if the fuel value is bigger or equal 120, and at the same time if we are increasing the value, so the fuel value increment is bigger than 0, in that case I want to animate the fuel value from 120 back to 0, which means that I will set the increment to be -1. And if we are on the other side of the animation, meaning that the fuel value is smaller or equal 0 and the increment is smaller than 0, I want to change the increment back to the +1. So we will play this animation in kind of like a ping-pong motion, so going from 0 all the way to 120 and then going back to 0 and repeat it over and over. Now what we want to do is to draw a black rectangle over the fuel gauge. And let me open the UHG2 documentation, and to change the color we need to call the setDrawColor function, with number 1 being white and 0 being black. So inside our code I want to draw the background image in the white color, and after that I will change the color to black, and I want to draw the rectangle, so just jump back into the documentation, and here I'm looking for the drawBox function, which draws the box on the X and Y positions with the width and height being specified. So I will just copy this example and paste it into our own sketch. And of course I need to know those X and Y and the width and height values. And for that I will jump back into Photo P and select this gauge background layer and then click the distances checkbox, which will show me the position as well as the size. So if I make this slightly smaller, I can fill in those values. The X position will be 5 because that's the X position of the gauge, but then we need to add the fuel value. The Y position will be always 2, so Y is 2. The width of the gauge will be 120 minus the fuel value. And finally the height of the gauge, as you can see in here, is 13 pixels. Before uploading this to the Arduino board, I will remove the delay because we want to animate it as fast as possible. And then I will click the upload button. And once this is uploaded, the fuel gauge is indeed being animated. Now it's not very fast, but before we try to make it faster, let's also animate the right gauge for the coolant temperature. And I will use pretty much the same code, but of course I need a few more variables for temperature value and temperature value increment, and then animate the temperature value in the very same way. And then we will draw one more rectangle using the temperature value. And the only thing that needs to change is the X position. So again, jumping into Photo P, I will select that layer, and it seems like that the X position is 131. So let's just change this to the 131. And let's try to upload it to the Arduino one more time. So now we have both gauges animated, and I would like to see if I can animate those faster because they are just quite slow. And what we are doing is we are drawing full screen background image and then drawing two black rectangles on top of it. But if you think about it, the animation is only happening on the top half of the screen. And the bottom half stays the same all the time, which means that we probably don't need to update this part of the screen, so we don't need to draw the full screen background image every frame. And I've mentioned it multiple times, we are using something what's called the page mode in the UHG2 library, where the display is split between multiple pages and every page has the height of 8 pixels. So what I think that we can do is to not draw all the pages, but only the first 2 or 3. So let's jump back into the Arduino IDE and create a new integer variable and call it current page. And when we jump to the first page, I will set it to 0. And then after we draw stuff to this page, I will increase the value by 1. And actually before doing anything, I want to see what is the current page. So if the current page is bigger than some value, for example bigger than 2, I don't want to do anything, so I'll just call the break function, and that will jump outside of this do while loop. So let's try to upload it to the Arduino to see what happens. And there are actually a few things happening. First of all, I think that everything is slightly faster, which is great. The second thing is that we probably are updating more than we need to because we are also updating those dots and lines which are not changing. So instead of updating 3 pages, maybe we can just update only 2 of those, but we will talk about it in a minute. And finally, of course, we are missing the bottom half of the image which we are not drawing inside the loop, but we should still draw it inside the setup function. So let's start with knowing how many pages do we need to update, and if I measure the size of our gauges, the height of our gauges, it's only 15 pixels. And again, one page is 8 pixels tall, so it's perfectly fine if we only update first 2 pages, so first 16 pixels. So inside the Arduino code, I will say that if the page is bigger than 1, then we will not draw anything, and let's upload it one more time. And it feels like that the animation is playing even faster. Actually, let me show you all 3 versions next to each other so you can have a comparison as for the speed. So all that's missing is to draw the full screen background image once in the setup function. And for that, I will just copy this piece of code and paste it into the setup function. But of course, I don't want to set the current page. And I don't need to draw those rectangles, only drawing the background image like so. And let's upload it one more time. So not only we have fast animated gauges, but we also see the rest of the image. That said, I think that we can still make it slightly better, because when the animation is playing, the top half of the gauge seems to be 1 pixel off from the bottom half of the gauge. And the reason for that is still the same, and that's because we are using the page mode, so we are first redrawing the first 8 pixels of the display, and then before we redraw the next 8 pixels on the display, we need to populate the frame buffer with a new data, and it takes some time. So there is a small delay between those updates, and it looks like that the gauge is made from 2 pieces. Thankfully, there is quite simple solution for that. And it's a page mode with the number 2 inside, and it means that instead of having a page which is 8 pixels tall, we will have a page that is 16 pixels tall. So actually all our gauges will fit on one page. Now switching to a different page mode is quite simple. We just need to replace this number 1 with the number 2. And then of course we only want to update one page, so instead of saying that if the current page is bigger than 1, I will say if it's bigger or equal 1. And then upload it to the Arduino. And that's it. Now the top half of the gauge is nicely aligned with the bottom half of the gauge and there is no misalignment. And again, I think it looks great. I would almost say it's my new favorite display, and I cannot wait to use it for my other projects as well. Now, if you want to learn more about the graphics and the U8G2 library, I have quite a lot of videos covering that topic, mainly using the OLED displays. I will put the links to those videos down in the description. By the way, here is also a preview of those individual OLED designs. If you want to show some real data on the display, I have a few videos about that topic as well. For example, about interfacing the boost gauge, the tilt sensor, the temperature sensor, or the parking sensor. If you would rather get this data from your car's OBD2 port, I have a video covering the topic as well. And finally, if you would like to use a color display instead of the VFD display, I have a video covering that topic as well. If you would like to see more projects using this VFD display, please let me know down in the comment section. If you have any questions or comments, please put those down there as well. That's it for today. Thank you very much for watching and I hope to see you soon. Thanks and bye.